Section 5.2, example 7, identify n behavior and degree of a polynomial function. Given the function f of x is equal to negative 3x squared times x minus 1 times x plus 4. Express the function as a polynomial in general form and determine the leading term, degree, and end behavior of the function. Wow, that sounds like a lot, but in reality, it isn't too crazy. So let's get started. F of x is equal to negative 3x squared times our x minus 1 times our x plus 4. So what they want us to do is put this in general form as opposed to factored form. So this is all factored. We could find the zeros if we needed to. I think we'll learn that a little bit later in this section. We could do a lot of things with this, but right off the bat, I don't see our leading coefficient just yet. But if we expand it, everything ends up working out for us. So let's expand it. I'm going to start by multiplying these two. You could start wherever you want. This here is just my personal preference. So we have 2 times x, or I'm sorry, not 2. X times x times 4, negative 1 times x, negative 1 times 4. So x squared plus 4x minus x minus 4. Let's simplify that. X squared plus 3x minus 4. And now we could expand by multiplying or distributing this to all three terms there, leaving us at negative 3 x to the power 4, negative 9 x to the power 3, positive 12 x to the power 2. And now from here, we could find our everything. So find general form, determine leading term, degree, and end behavior. So starting with our leading term. So leading term, degree, and lastly, our end behavior. Leading term is going to be the term with the highest degree. So it looks like it's going to be this one here. So leading term is negative 3x to the power 4. Degree is our exponent, or our variable. X to the power 4, so degree 4. And end behavior. So end behavior, we could start plugging it in as x approaches. So from the left side, we have negative infinity. Our function f of x approaches what? And also as x approaches, so we did left side, now the right side, positive infinity. Our function f of x approaches what? So here we have degree 4. So it tells us that these two are going to be the same. Negative 3 tells us that it's going to be both down. So as x approaches negative infinity, our function f of x approaches negative infinity. As x approaches positive infinity, our function f of x approaches negative infinity as well. So again, we got all of this based on just the degree and the leading coefficient. And that's it. If you have any questions, please feel free to ask. Otherwise, bye.